In this last screencast, for chapter 11, we are going to talk about some properties of alkanes. And one of the things that they introduce in this chapter are homologous series. And a homologous series is just a series of compounds where each member differs from a previous member only by having one additional unit. So a homologous series is where if you have any series of compounds where each member differs from a previous member only by having an additional unit. So for example, this is a homologous series. Now, I want you to notice that the physical and chemical properties of these, particularly the physical properties that we're looking at right here, melting point and boiling point, as well as density, are pretty closely related, but vary in a really systematic and predictable way. So what do I mean by that? What we can see is that the melting point increases in alkanes as the number of carbons increase, and this is because we have increased intermolecular forces. Same thing with boiling point. As we increase the number of carbons, we have more intermolecular forces until we end up with a higher boiling point. And we see that density increases as well. Now, a few things to kind of keep in mind about alkanes are that alkanes are composed of carbon-carbon and carbon-hydrogen bonds. And so because of this, they are nonpolar molecules. So these are going to be nonpolar molecules. They also have lower melting and boiling points than other organic compounds of similar molecular weight. And this is because they are not polar, so they can't form dipole-dipole interactions, and they can't have hydrogen bonding, which is going to influence the boiling point and the melting point there. So this is because they have very weak attractions to each other. Another thing to be aware of is these tend to be odorless compounds. So one of the things to be aware of is that when we look at this, the boiling points of normal alkanes increase really smoothly as the length of the carbon chain increases. This pattern results from increasing dispersion forces as the molecular weight increases. And so at ordinary temperatures and pressures, normal alkanes with carbons numbers 1 through 4 right here are gases. And so this would be like propane gas, methane gas, ethane gas. These are gases. Then carbons 5 up to about 20 are liquids. And then if they have more than 20 carbons, they are waxy solids. So if we have things with more than 20 carbons, they tend to be waxy solids. Now, because these are nonpolar, alkanes and other hydrocarbons are insoluble in water. because water is a highly polar solvent. They are also less dense than water. So they float on it. It's why when it rains, if you've got any oils, which are hydrocarbons, those will float on the top of the water. It's very slick when it first starts to rain. These two properties are also partially responsible for the side effects of the oil spills from ships, right? So if there's an oil spill from a ship, we see that the oil will float on top of the water. Now, liquid alkanes of higher molecular weight generally behave as skin softeners when applied to the skin. So an alkane mixture known as mineral oil is sometimes used to replace natural skin oils. Petroleum jelly, which is Vaseline as its name brand, is a semi-solid mixture of alkanes that's both used as a skin softener and a protective film. And then water and water solutions don't dissolve or penetrate the film, and so that underlying skin is protected. And so one of the things to be aware of here is we're also introduced to the idea of things that are hydrophobic. And hydrophobic means water fearing. Right? And it's often used to refer to molecules or parts of molecules that are insoluble in water. So molecules or parts of molecules that are insoluble in water. So a lot of biomolecules, for example, will have a nonpolar or hydrophobic part that resembles our alkanes. So for example, this is palmitic oil, and you can see that we've got a large nonpolar portion that resembles the alkanes. And then we also have a portion over here that is more water soluble, and it's got the carbons and the bonded to the oxygens here. So this is a carboxylic acid functional group. So these alkane groups will pop up again when we talk about lipids particularly. Now, let's talk about alkane reactions. Alkanes are the least reactive of all organic compounds. In general, they don't react with strong acids or strong bases or oxidizing agents or reducing agents. So very unreactive. However, they do undergo combustion, and so, which is also rapid oxidation, where they will burn in air. And so if you have methane gas, it will burn and produce CO2 and H2O, and then a lot of heat as well. And so this is the reason that a lot of hydrocarbons are used as fuel, is because they will undergo this combustion reaction. Now, another thing that alkanes will undergo is something called an incomplete combustion reaction, where there's not enough oxygen available. And so a few things that can be produced there. One is carbon monoxide, which is really dangerous. And so it's why that you're never supposed to, for example, use your gas grill inside, because you don't want to produce any carbon monoxide. And that's why we have carbon monoxide sensors in our homes and alarms to help us with that. Now, one of the things that's interesting is if there's an incomplete combustion, you will also form just carbon by itself. And this is called carbon black, and it's used in a lot of paints and pigments to give a really nice, beautiful, light, fast black color. So sometimes these incomplete combustion reactions are done deliberately, specifically when you are making paint pigments. So this ends our journey in chapter 11, and our kind of journey into the introduction to organic compounds and alkanes and how to name them and their properties and how they react. If you have any questions, please feel free to stop by my office.